yesterday, but pretty much what we're doing is we're starting 4.3 is on page 153. We are learning how to solve inequalities. So we spent the last two sections of this chapter learning about equalities and sort of had started the process of solving them. This one takes it a little more in depth. So there's one thing really quick that I want to have you guys look at. When we compare, like yesterday, we did the lesson opener, which was just solving equations. That's what we did ages ago. So if I have an equality saying that x equals 4, does that mean the same thing as 4 equals x? X equal 4 and 4 equal x, the same statement.
Yes. Oh my gosh,
Yes. All right, yes. This is the symmetrical property of equality. Well, sort of. The symmetric property of equality means what you do to one side, but it's pretty much the commutative property. X equals 4 is the same thing as saying 4 equals x. Now, what if I said that x is greater than 4? Does that mean that 4 is greater than x? No. They mean the exact opposites of each other. So remember, if you ever solve a problem and you end up with your answer, somehow your constant answer is on the left and your term or your variable is on the right, and you need to switch it, make sure that you also flip that inequality symbol, okay? So if I said that 4 is greater than x, does that mean the same thing as x is less than 4? Yes. Those are the same. Okay. Just wanted to review that really, really quick. So now that that has been demonstrated, let's go into this actual lesson. So pretty much all this is we are solving inequalities in a very similar way that we solved equations, but there's a few noticeable differences that I want to make sure we get some practice in. They do still have addition and multiplication properties. And we still use the distributive property to simplify the left side and the right side, and then we solve for our variable. So let's do some practice with those. So on page 153, we have example 1. Oh, that's weird. My pen will not work. There we go. Example 1. So in example 1, we have 3x is greater than 15. So remember, in the previous unit, we solved for x and then created a solution that would work with a particular inequality. So in this case, what do we do to isolate our variable x and create a solution? Right. This is an easy one. We divide both sides by 3. Is 3, excuse me, let me ask this a different way. Do we need to flip our inequality symbol? Because we're multiplying. Why? What do we have to have in order to have to flip? It has to be a negative number. Because 3 is positive, our inequality stays the same, and we get the answer x must be greater than -5. As long as it is, then that means that this statement up here is a true statement. Okay, example 2. Interesting. Hold on, where did that come from? Oh man, I hate when I do that. Let me get a different one. So example 2. Gives us the inequality -x over 3 plus 8 is greater than or equal to 12. Okay, so remember, when we see a negative fraction, so let's look at the example -x over 3. How could you rewrite that so that your negative is only is attached to one of the either the numerator or the denominator? that means the same thing as negative x over 3? I couldn't ask that question in a way that made any sense. So look, a negative divided by a positive gives you what kind of answer?
No, a negative.
A negative. How about a positive divided by a negative? Is your solution still negative? Yes. So if you see a fraction and part of your fraction is the variable that you're having to solve for, then throw that negative in the other part of the fraction. So in this case, because we have negative x over 3, how would y'all want to rewrite that? Where do you want to put your negative? You don't know? Anybody know? You could put it with the x. You could put it with either one. But which one makes more sense? We got to get rid of the 3 anyway. So why don't we just stick it with the 3? Does that make any sense to you guys? Because I see this missed a lot.
I mean, I don't know like that. I just automatically think that it's
As long as you, okay, so as long as you recognize that it's negative and you need to get rid of the negative, it needs to leave the variable. You can't leave your variable negative, then you're fine. But a lot of people just forget it's there and ignore it. If they don't know what to do with it, it just sort of disappears if they don't copy it down when they go to their next step. So I would learn that if you have a negative fraction that includes one of your variables, it doesn't matter if it goes in the numerator or denominator. So just stick it with the constant so that when you get rid of that constant, when you isolate your variable, you take your negative sign with it. Okay, back to topic. So if we were going to solve this for x and create a solution for this inequality, what's the first step we need to do to isolate our variable? Reverse, sorry. Yes, we use reverse order of operation, just like we do with equations. We are subtracting 8 from both sides, which leaves us with x divided by negative 3 is greater than or equal to 4. All right, so the second step we need to do is what? Yes, multiply both sides by negative 3, which is also multiplying both sides by the reciprocal of negative 3, which is negative 3 over 1. Either way. And so you see that those cancel each other out. And how do we write our final inequality?
who's less than or equal to negative 12.
This?
Yeah.
Look at you, big brain. Right? Because when we multiply or divide by a negative number, we must do what? Yeah, you got to flip that inequality, reverse it. Yes, so as you can see in example 2, that all of a sudden during that step where you multiply both sides by negative 3, you have just flipped your inequality sign. All right, so I'm going to skip 3 for a second. Let's move on to example 4 and 5, and then we'll start getting some practice. So example 4, we are doing some simplifying. We have x plus 4 is greater than or equal to 5 times x plus 6 minus 2x. All right, Gabe, what do I need to simplify first? That guy's about as simple as he gets.
Yeah, distribute those. So it'd be 5x plus 30.
Okay. And Eden, what do I need to simplify next? I still need to simplify this side. Do we have some like terms? Yes. And what do we add to that 2x? Yeah. Whenever you have a minus sign, just add it to the term following it. So you make sure you include that negative when you're combining like terms. So this becomes 5 minus 2x, which is what? Right. So this side becomes 3x plus 30. Now, is both the left and the right as simple as it gets? Yeah. All right, so what's the next thing we should do here, Andrew? Huh? Okay, so we need to move some things around. We need to get all like terms on the same side of the inequality. So what's the first thing you would do?
3x plus normal x, right? 4x.
So what are we wanting to do? Are you wanting to move the 3x over here? So what do we do to get rid of it on the right?
Oh, we divide by 3x. We subtract by 3x.
We subtract 3x, and that makes that go away. But if you do it to one side, so it becomes
-2x.
-2x plus 4.
Oh, I'm just doing it wrong.
No, this happens a lot, and that's why I like that we're getting a little bit of extra practice with this, because you are so used to seeing a coefficient in front of a variable and trying to separate that coefficient from the variable that you forget you're just looking at a positive 3x, which when you know the value of x is a number, it has a value. So you move them together, which means you subtract. So what else do we need to do? Subtract 4 from both sides. And we're left with
-2x is greater than or equal to 13. No, yes, no, wait. 26, because then you divide that by -2 and it's -13.
okay. I was gonna let somebody else do that, but good job.
Okay, yeah.
That's okay. We'll roll with it. We got more.
I'm thinking a couple of steps ahead.
I got all kinds of problems up my sleeve. No, we're good. So when we, it's so nervous. So when we divide by -2x on both sides, what is our final solution? X.
Oh my gosh. X is less than or equal to -13.
All right, so everybody saw what we did. We divided both sides by -2. Just like when we multiply, if we divide or multiply by a negative number, we must flip our inequality. You don't like this game? No, you just like the fact that what you mean to say and what comes out of your mouth are two very different things. That's okay. That happens a lot in math. Just ask Gabe. He's like, no, I meant. I'm just teasing. It happens to all of us. No, probably mostly me. How many times do I go, wait, nope. That's not what I meant. Okay, let's look at example 5 and then we're going to do some additional problems. Last one. Would you quit whining? Take that as a no. All right, we have a word problem. Example 5 says, Jeffrey wants to fence in a rectangular garden and he has up to 60 feet of fencing available. So he wants to build a fence around a garden. Got a hill garden. Just because it's math doesn't mean you can't be creative. Looks just like a garden, doesn't it? All right, and he has, I lost my place. He has up to 60 feet of fencing available.
60 feet. Yeah, I need 60 for the fencing on that.
Right? So he needs the whole thing. I'm gonna, hold on, let me do this. I'm gonna say A, B, C, and D. What kind of C is that? So he needs A plus B plus C plus D to equal 60 feet. I don't know if we necessarily need this, but that's how I like to do it. Okay, so he has 60 feet of fencing. If the width must be 5 feet more than half the length, what are the possible dimensions of the garden? This is so non-realistic. Nobody comes to build a fence like this, but that's okay. We'll figure it out. All right. So let's define our width. The width must be what? 5 more than half the length. So how do we write 5 more than half the length?
Length plus 5.
So we have, it must be 5 more than, which in this case, that's just addition,
Oh, and it's 2. Okay.
than half the length.
Yeah.
So the width must be half the length plus 5, at least. That's going to be our inequality statement. And then the length just equals the length. So you see how that way the width and the length both can be expressed in the terms of one variable? This is sort of like those accounting problems we had when we were studying money, when you have the 2 separate accounts. So that means that the width plus the length must be at least 60, right? What symbol do we use to signify at least? Hold on, let's finish this problem. Less than, right, at least. No, wait, no, I said that backwards, didn't I? You all right? That chair is a little wonky. I'm sorry, I did say that totally backwards. See, I told you, I always say the opposite of what I mean. It can be no more, he only has 60 feet of fencing. So it can be 60 feet, but it can't be any more than 60 feet. So not at least, at most 60 feet. All right, so what do we put in the place of W? What does W?
The width. So we put that fancy little equation in there.
We put 1/2. The width can be, I think that's the one that said least. It can be, it must be 5 feet more than half the length. So half the length plus 5 plus length is less than or equal to 60. See how we defined the width in terms of length, and then we plug that definition in. So we only have one variable now. And of course they show it as, what's another way we can write 1/2 length? That's the same thing as length divided by 2. So that's how they show it in the book. And you can do that if you want to. If we do that, we have length over 2 plus 5 plus length. So what do we need to do first? We have some like terms. So we need to combine those. So we have length over 2 plus length over 1. So we need to multiply the numerator and the denominator by 2 because we're adding fractions. So that ends up with length over 2 plus 2 length over 2, which gives us 1 plus 2 is 3 length over 2. So 3L divided by 2 plus 5 is less than or equal to 60. All right, so Abigail, what's the first thing I do to start isolating my variable? You have to do your reverse order of operation. So what do we do? Exactly, yes, good job. We subtract 5 from both sides because this is reverse order of operation to solve the inequality, and we're left with 3L divided by 2 is less than or equal to 55. Now, what's the last step we can do to isolate our variable? We got to get rid of the 3 over 2. So remember, this is the same thing. I'm showing you this is the same thing as 3 over 2 times L. And what's the reciprocal of 3 over 2? Yes, 2 over 3. So you can just multiply both sides by 2 over 3. Did they do it that way in the book? Oh no, they got rid of the fraction.
That's why I would have done it too.
Yeah.
Or just go decimals.
Because these disappear and it's positive. So do we flip our inequality sign? No. Okay, so 55 times 2 is 100 plus 10, so 110 divided by 3. And that's where you get, they changed it into a mixed number, which is 16 2/3. Because 3 goes into 110 16 times with a remainder of 2. So the length must be no more than 16 2/3 feet. All right, let's do some practice. These are additional problems, so they are not in your book. So please make sure you work through these neatly in your notebooks so that you have them as examples. We are going to finish 4.3 tomorrow, and then we're going to do our review for 4.3 on Friday. And then they want us, our quiz, next quiz is just over this section. So unfortunately, that means we're going to have another Monday quiz. I know, I thought it was going to be 4.3 and 4.4, so we were just going to. Yes, now you can go get some water. Quickly, because you're going to need these. All right, okay, so additional. All right, additional problems. So we're going to go through this and take turns. Don't worry, my computer mic actually doesn't pick up y'all's voice over there. Unless you yell. You can yell. But my girls in this class are fairly soft-spoken as long as they're at school. Well, I mean, I've seen her on the basketball court. Was it basketball last year? You play basketball, don't you? Okay, that's what I thought. Last year I got to go to games. This year I did not. All right. Oh, you want to start us off?
Yeah.
You can do this. Okay, so we have 2x minus 6 is greater than or equal to 4.
Yeah.
So we add 6 to both sides.
And 2x is greater than or equal to 10. And you divide both sides by 2. And you get x is greater than or equal to 5.
Well done, son. This is clicking, right?
Yeah. I love that.
All right. Do we already all have this worked through? Okay. Neatly, so if you needed to look at it again, you knew what it meant. There he is. You only missed one. Good job. It's like the easiest one. You could do it in your sleep.
We had no cups.
Aw.
Jake does this classes. Room temperature.
Yep. All right. Girls, one of y'all can pick the next one. It is, I don't care. We'll just move around the table. Which direction, doesn't matter. This one is 4y plus 6 is greater than 6. Who wants this one? Okay, what do we need to do? Okay, so we subtract 6 from both sides and we end up with, you do end up with 0. 4y is less than 0. So what do we do to isolate our variable? We divide both sides by 4. So we divide 0 by 4. What's 0 divided by any number? Yeah. Does our inequality stay the same? I kept it the same. Is that right? Right, because we did not divide by a negative number. All right. Even number 3. 3 says 4x plus 8 is less than 44. Okay, what do we do first? Yes, we subtract 8 from both sides. We're left with Yep, 4x is less than, well, 44 minus 8. We know minus 4 is 40. So 40 minus another 4 is 36. Yeah. So, which is nice because 4 divides evenly into that, right? And we need to do what to both sides? Right. Does our inequality stay the same? Right. Nope, not equals. Don't add stuff. And 36 divided by 4 is 9. Yeah, not bad. Number 4, Abigail, is negative 3x minus 6 is greater than or equal to negative 24. All right. Sorry, they just started getting a little more complicated. Right. We add 6 because that gets rid of it on the left and adds it to the right. Literally this time. Negative 3x is greater than or equal to negative 24 plus 6, like or unlike. Right. So we find the right. So 24 minus 6. Close. Is it positive or negative? Right, because our larger number, 24, is the negative number. So we're still negative even when we add 6. All right. So once you're finished, yeah, what do we do next? Okay. And do we need to reverse our inequality? Yes. Why? Right, because we're dividing by a negative. So what's my final answer? X is it 6 or negative 6? Right, because a negative divided by a negative is a positive. Very good. All right. Mostly you just have to remember, what do you ask yourself as you multiply and divide? Okay. Gabe, number 5. 5 is x divided by 8 minus 2 is less than or equal to 0. What do we do first? Add 2. And we end up with what? X over 8 plus 2. Negative 2 plus 2 is plus 2. Well, that's why we added 2 to both sides. To get rid of it. Mm-hmm. Okay, keep it the same. Less than or equal to 2. All right, and what's the next step we need to do? Right. All right, and do we need to reverse our inequality sign? Okay, so it stays less than or equal to. Yep. And that's our solution. X is less than or equal to 16. Okay, next one, back to you, Andrew. 7x minus 9 is greater than negative 37. So we add 9 to both sides. 7x
Is greater than negative 28.
Okay. Yeah. I think so. Because they're negative and positive, so they're unlike. Yep.
Then you divide 7 by those sides, which you will get negative 4.
Okay. What's our full inequality?
Sorry. X is greater than negative 4.
Why didn't we switch it? We divided a negative.
Or divide 5.
Right. Because the 7 was not negative, We don't flip our inequality. Yes. So.
Man, I'm so.
Right. If you're not sure, once you've solved it for x, plug it back into your original equation. So in this case, it says we've decided that x, as long as x is greater than -4, then our original inequality, 7x minus 9 is greater than -37, will be true. So pick a number greater than 4 or -4. So you pick 4, or don't be crazy. Or you pick -3, as long as it's right greater than -4. So just pick the next number, plug in a -3. What you find is -3 times 7 is -21. -21 plus 9 is, no, it's not. Is that right? -7. -21, that's -30. Then it's wrong. But it's right.
We have time for one more?
We have time for 4 more.
1925. Oh no.
It's only 218.
Huh?
It's only 218. Let's look at that. X is greater than -4. -3. 7 times 3 is 21. 21 plus 9 is 30. Oh, yeah, -30 is greater than -37. We just all were like, yes, we were all thinking of it in terms of positives. Okay. Dirt. Told you. All right, number 7. So this one's whose? You just did that one, right? Okay, so this one's Ian's. Number 7 is -4x. So Ian, this one's yours. -4x plus 16 is less than -32. All right, so what do we need to do? Right, we subtract 16 from both sides. What happens when we subtract a number from a negative? Right, yeah. So 6 plus 2, 3 plus 1. All right, so what's my full inequality up to this point? Okay. So the next step. Yes, divide both sides by -4. All right, so once I do that, what is my final inequality? What's my solution? X first off, if we're dividing a negative by a negative, we know our answer is going to be what? Right. 4 goes into 4, how many times? 4 goes into 8, how many times? And we end up with 12. So X is greater than 12. Good job. All right, we're getting this. All right, next one, number 8 is 5x plus 9. All right, we're going next level again. Just a little. It's greater than 7x minus 3. So what do we need to do here? Which one do you want on the left and which one do you want on the right? We can subtract 9 from -3. And we're left with 5x is greater than 7x minus 12. Okay. Now what do we need to move? You need to move the x too. So treat 7x, it's one term. So you got to move the whole term. So what are we actually subtracting here? Right. So when we do it from that side, we do it from this side because those are like terms. And 5 minus 7, -2x is greater than -12. All right. So last step, what do we need to do? Just -2. Right. And so then we can solve for x. So give me my final inequality. X. Very good. Yes, so first off, we had to flip our inequality because we divided by a negative number. Second, because we were dividing a negative by a negative, our solution ended up being positive. And that is correct. All right, Abigail, number 9 is 7 times x minus 2 plus 5 is not equal to 2x plus 15, sorry, minus 3x.
Wow, Miss Klein.
So fun, right? Okay, so let's just look at the left until we get it as simplified as possible. Then we'll just look at the right, so simple as possible. Then we start moving back and forth across our negated equality here. Okay, so 7 times x minus 2 plus 5. What do we need to do here? Right, so 7 times x. Minus 14 plus 5. Okay, we'll leave that like it is for right now and let's look at the right side. Is there anything on the right side we can simplify? Right, so our x term becomes what? You treat this like a negative 3x, yes. So 2 minus 3 is right, but when we put that in front of a variable, we just call it exactly. Good job. Negative x. And then we only have one constant, so we'll leave that one alone. So I think at this point, the right side is as simplified as it's going to get. We still need to simplify a little bit on the left, though. So what do we need to combine on the left once you're done writing? Right. So are they like or unlike? So 14 minus 5. That's our difference is 9. Is it negative 9 or positive 9? Negative, because the 14 is the larger number. So 7x minus 9 is not equal to negative x plus 15. All right, so what do you want to do next? Yeah, so you want to, so we move x to the left, so it's all on one side. So we're adding x to both sides. Yep, let me do that first. I like to do that first, get my variables all together. And so this is what? It's 8x. Remember, x by itself, it just understood 1, so 7 plus 1. So 8x minus 9 is not equal to 15. All right, so our next step does what? Yep. So let's, and is it? Don't you love that? So it's going to be 8x does not equal 15 plus 9, 24. All right, last thing. Yeah, let's divide by 8. And we end up with x does not equal 3. That's all right. We can do one more.
What if it's another one like that? That one took 5 minutes.
We'll be all right. All right, Gabe, last one. 2/3 x plus 5/8 is less than 5/12. This one's not too bad. Because
Me, I would turn off the lessons.
see, and what should we do? We can get rid of all these fractions. Yeah, what does 3, 8, and 12 all divide evenly into? What is our least common multiple? Yeah, so multiply everything times 24. 24 times 24. All right, 3 goes into 24 how many times? 8 times 2x plus 8 goes into 24 how many times? Right, we just figured that out. And 12 goes into 24. I think I have been saying 25. 2 times. Yeah, I know this. 2 times 5. All right. So simplify. 8 times 2. X plus is less than. Right. First step. Yes. Remember reverse order of operation. Ugh. It's not even, but we're just going to leave it as a fraction. What do we do? By? Yes. And our final answer?
Negative.
Right, but what has to be negative? The number we're actually doing the multiplying or divided by. So because 16 is positive, we leave our inequality sign the same. So our answer is X is less than negative 35 over 16. All right, and you guys are free. Okay, I was almost done. I need to fix an error that I made here. When I did 3 times 5 up here, I accidentally put the solution in here instead of the 5. And so that meant everything else ended up wrong. So this is actually 15, which means that this is 15. Which means that this is 10 minus 15, which is negative 5. So our solution is actually negative 5 over 16, not negative 35. Sorry, hope you're using a pencil. So yeah, so our final solution is X is less than negative 5 16ths. All right, that is all. Thank you very much. See you later.